Now that you have mastered drawing to the game screen and preparing your variables in a way to best control all the different things you want to draw on your screen, you're ready to start making things move. We first need to understand the game loop. A game loop is the cycle that your program goes through, usually 30 or 60 times per second. That's 1 second, and in that 1 second, the game loop just ran 30 times. Let's divide this second into 30 pieces. Each tiny piece of this full second, the game loop completes 1 full cycle, and each cycle is called a tick. It can also be called a frame. Let's zoom in and see what is happening within each game loop. The simplest game loop can be split into 2 parts, the update and the draw. Update is where the program handles input from the player and makes changes to everything that needs changing in your game. It will run all the code and logic that updates the game's current state in order to keep up with the player's button presses. After that is completed, the second half of the game loop, draw, deals with rendering, which is the processing of any visual output you will eventually see on your screen. And after that, 1 tick or frame is complete. Then it loops back to update to repeat continuously, 30 times or even 60 times per second. Now that you understand the game loop, let's head over to PICO-8 and learn how to use it. I'm actually going to walk you through the game loop backwards, by starting with draw, since you already know how to draw things to the screen like this. CLS to clear the screen, and we'll draw a circle at 60, 60, with a radius of 30, and a color of 7, white. If we run the program right now, then we see that it did those 2 things. The screen is cleared, and then the white circle is drawn near the middle. But we are also back at the command line, meaning the program ran only once, and then stopped. There is no continuous game loop happening here. We are just running the code 1 time. In order to run the full game loop, PICO-8 looks for a specific function that is already programmed to run every tick. The function for the drawing half of the game loop is appropriately named draw. And just to make this keyword more unique, there's always an underscore in front of the word. Now we can't just use the draw function like we do with CLS or circ. We actually have to set the function up and place our code inside of it. Let's set up the draw function by writing the word function, then a space, then the name of the function, which is underscore draw, and then open and close parentheses. And you don't have to put anything inside of these parentheses because this is a special function that's going to be run automatically and doesn't need to be given any data. The draw function just needs to be given code inside of it. Now that I'm at the end of this line, I love using this shortcut of Shift and Enter to automatically write the end of a function. And now we have a nice block of code with a start and an end. And any code we put in between will be run continuously as part of the game loop. So let's move our code up and inside of this draw function. I see a lot of new programmers leave their code like this, but remember back to when I talked about the formatting of code being like a dictionary, and how important indentation is. So since this is inside of the function, we need to indent once with the tab key. Now we see the dark purple lines on the left that connect the start of the function to its end. And our code now sits visibly inside of this draw function. When we run this code, we are no longer kicked out to the command line because our program is now running continuously. The game loop is looping. And even though we don't see anything changing, PICO-8 is clearing the screen and redrawing this white circle over and over again really fast. When the game loop is running like this, we need to press escape once to go back to the command line, and again to go back to the editors. And next, we want to be able to change how the circle is drawn. To make things able to change, remember that's the exact meaning of the word variable, so obviously we need variables. The data inside of circ are the position coordinates, x and y, the radius, and the color. So let's make variables for those. X equals 60, Y equals 60, R for radius equals 30, and C for color was 7, but let's make it 8 this time, red. Now we can replace the number data with the variables. Run it, and now we have a continuously drawn red circle. Next, let's start to use the first half of the game loop, the update. Just like draw, the name of the update function is simply the word update, with an underscore in front, and it also needs parentheses in back. The order of where these functions are written doesn't really matter, so we could add the update function to the bottom and it will run just fine. But I like to organize my code as best I can so that it reads from top to bottom in the order that it is run. So, since we know that the update always comes before draw in the game loop, I'm going to write it before the draw function up here. Function, space, underscore, update, parentheses, and make sure to end it. Alright, we have our variables, we have our update function, and our draw function, and together these form the full game loop. Now I want to point out that there's nothing stopping you from drawing things in update, or updating things in draw. In fact, we can cut these two lines of code from draw and paste them up into update, and run this. It works fine, no errors or anything. So then why do we have two different game loop functions? Well, there are 3 reasons. Most importantly, there is an order to when they run, and update is always run before draw. To demonstrate that, let's draw 2 circles and fill them both with color. The first circle will be more left, so x minus 20, and the second circle will be more right, x plus 20. Finally, let's add 4 to the second circle's color, and that should make it blue. Alright, let's see what it looks like. Perfect. 2 circles with a blue one in front of the red. Looking at the code, we can see why. The first circle is the red one, and we can add comments to make it clear. Then we draw the second circle, which is blue. Remember that the draw order is like layers, so moving red down, we can bring it forward and draw it on top. Right, now we can move everything down back into draw, where they should be, but we'll leave the red circle up inside of the update function. Run it now, and the red circle disappeared. Let's study the code to find out why. First, we set the variables. Then update runs, and draws the red circle. Then draw runs, and it clears the screen. So the red circle is basically erased before drawing the blue circle. That was easy to figure out because we wrote the code in the same order that the code is run. But what if we wrote the update function after draw? It still runs the same because we know how the game loop works. But when reading your code, you might forget and assume that it still runs from top to bottom. In that case, you think it clears the screen, then draws blue, then draws red, and it can be hard to understand why red is not even visible. Let's take clear screen and do it only one time, before update or draw is run. And now we see the red circle again, but it is still behind the blue, even though in the code the draw function is written first. Okay, so you need to remember, when PICO-8 starts the game loop, the update function automatically runs whatever code is inside of it before the draw function runs whatever code is inside of it. That's why I prefer to write my code as close to the same order that it will run as I can. So let's bring update above draw again. We also just proved that you could put drawing code in the update function, which brings us to the second reason why we have these 2 separate functions in the game loop, and that is organization. You should use these 2 functions to separate your code into 2 categories. Update for any of the logic in the game, checking for buttons being pressed, moving characters around, checking for collision, changing your variables, and anything else that prepares your game before it should be drawn to the screen. Use the draw function for any code that handles actually drawing to the screen. And it is a good idea to clear the screen every frame as the first thing that you do in your draw function. And because we do this, even though I could draw things in update, anything drawn would just get cleared by the draw function anyway. So let's keep it nicely organized and move all drawing code back into draw. I did say that there were 3 reasons, and the last reason you should just be aware of, but you probably won't need to worry about it until you start doing tons of processing in your game that will make it slow down. If that happens, and your code inside of update takes too long to process, then PICO-8 will skip the draw function for that frame. In PICO-8, you shouldn't have to worry about that unless you plan on going crazy with calculating 3D environments, or adding realistic physics, or way too many particle effects. And some people in the community really enjoy pushing those limits. And maybe that's you in the future. So just be aware that if update is too slow, then draw will sometimes get skipped. Alright, so now you know why we have these two functions. Update runs before draw, they help us keep our code organized, and draw can sometimes be skipped if update takes too long. Knowing all that, we can now use the update function for what it's meant for, updating the variables to change how things are drawn later. To update the variables, we just need to change the value that is being stored in the variable name. Let's say we want to change the color again. So we write C equals and give it a new value, 10. And now we get a yellow circle and a pink circle. That's because 10 is yellow and 10 plus 4 is pink. That's how easy it is to change variables in the update function. But now I'm going to do something that might look very strange and confusing. I'm going to change this number to C. Now most students, when they see this for the first time, think back to their math class and read C equals C as very obvious. C is the same as C. Duh. But you have to remember that the equal sign means something different in programming. In math, the equal sign is there to just say whatever is on the left is the same as what's on the right. It doesn't do anything, it just states a fact. But in programming, the equal sign actually does something. It performs an action, and we call it an operation. Just like addition and subtraction actually do things and make changes to numbers. The equal sign here is setting whatever value is on the right to the variable on the left. Let me say that again. It takes whatever value is on the right and stores it in the variable on the left. So we need to remember that and read C equals C as setting the variable C to hold the value of C. And I know that can still sound confusing, because now you're probably thinking, what's the point of this? It's like a snake eating its own tail. Or if you're thinking about variables like we show as envelopes or boxes, then you might be thinking of it as taking a box and putting it inside of itself? And that just breaks your brain, right? But it's not actually doing that. It's really much more simple. The trick to understanding this is to read what's happening backwards. We get so stuck on reading from left to right that we think the logic flows in that same direction. But actually, the logic flows backwards here, and if we read it backwards, we can see that this C on the right is not the variable C. It's not the container. It's the value within, which is 8. And this C takes that value out of the container, and then the equals sign sets that value into a variable named C, which just so happens to be the variable we took it out of. Let's run it to see if anything breaks. Nope, we're fine. So all it's doing here is taking the value out and putting it back in, then drawing a red and blue circle, then updating again, which takes the value out, then puts it back in, and draws again, over and over, and that's our game loop. That's why setting a variable to itself doesn't break anything or give an error. And now we can do something cool, because we can take the value out, add 1 to it, then put it back in. To visualize it, we are taking the value out, adding 1 to it, then putting it back in. Okay, so let's get ready to run this code. But not yet. This code needs a serious flashing warning before running it, because the colors are going to change very quickly, and the PICO-8 colors are pretty bright. So to make it easier on our eyes, I'm going to remove this second circle, make the circle just an outline, and draw it near the center. Let's also print C so we can see the value of the color variable as it changes. Okay, here we go. Awesome! Our game loop is changing what is being drawn on the screen all by itself now. Pause here and try to explain to yourself or someone else what every line of this code is doing through multiple game loops, and why we see so many colors so fast. Alright, now if you walked through it and worked it out correctly, you might actually have noticed something strange and have a question about color numbers. If you know what I'm talking about, then hold that thought, and I'll be sure to explain. First, let's make sure everyone is on the same page and walk through it together. Okay, so we start by setting up the variables of the circle. The position at 60, 60, the radius, which controls the size, at 30, and the color starts at 8, red. The update function runs first. All it does is takes the value of C, which is 8, and adds 1 to become 9, then stores that new value 9 back in C. That's it for update, so now the draw function runs. First, it clears the screen, drawing black over whatever was there. Then draws our circle using the data stored in our variables. But what color is the circle the first time the code runs? It's not red, because C is not 8 anymore. It's already been updated to 9, which is orange. And we would print the number 9 to the screen. We can confirm this by forcing the game loop to stop, by using a function named stop at the end of draw. This will make sure that we are only running the game loop one single frame. So run it, and yeah, it's orange because C is 9. Okay, so now if we don't stop it, then the draw function ends, and the game loop loops back to update, and it takes the value out of C, which is still 9, because the code up here doesn't get run a second time, so C is not getting reset back to 8. The game loop only runs update and draw, update and draw. So on the second frame, C is still 9, and we add 1 to it again, so the new value is 10, and it's stored back in the variable C. And now draw clears away the orange circle and redraws the circle, but this time the color is 10, yellow. And remember, that's just 2 frames of the game, which is running at 30 frames per second. And that's why we are seeing the color change so fast. By the way, if we want to speed it up even more, then we use _update 60 here instead. And that function runs the game loop 60 times per second. And you might want to use this for action games to make things look smoother. But we'll keep it slower at 30 for now. Anyway, let's keep going through the frames. Okay, so that's the second frame done. We loop back to update again, and now on the third frame, the color value was 10 and increases to 11, and so then it draws a green circle. Now just keep imagining what's happening in the code, but we'll focus over here looking at the PICO-8 colors and count up every frame of the game loop. On the fourth frame, the color becomes blue, 12, then indigo, 13, then pink, 14, then peach, 15. And then what? If you thought this far ahead already, well done. And so the question is, what happens to our color number if we make it go higher than 15? Well, you might expect it to error, or maybe just go black and not accept any numbers that are not one of the 0 to 15 color numbers. But PICO-8 is actually prepared for this, and it figures out how to loop back through the color numbers when the value it gets goes above 15 or even below 0. So on the next frame, our C variable does become 16, and PICO-8 doesn't change that. It just understands 16 as restarting the color numbers, and it draws a black circle. And it just happily keeps going through all the colors. 17, dark blue, 18, dark purple, etc. Now before we run it again, let's slow down this process, because changing the colors every frame is too fast for our eyes and brains to even keep up. So instead of adding 1, let's add 0.1, and let's run it. There we go. Much easier to see it changing now. Notice the C value being printed in the top left corner. The tenths place is changing super fast, because that is what we are changing every frame. But the color doesn't actually change until the ones place changes. That little disappearing act it's doing, like there, is just when the color value loops back to black. So it's still drawing, but we just don't see a black circle on a black screen. So it's still working exactly as expected. And that's how the game loop works. Now to make your understanding very clear, let's go ahead and experiment with it. Just like we are changing the color variable, let's also change the x. X equals x plus 1. And we'll also print x. Run it, and there it goes. And it just keeps going. Alright, how about -1? Yep, now it moves to the left. And you should play around with changing the different variables in different ways. Like, how about we change the radius? Now our circle is growing in size. See what else you can do. And make sure you are predicting what you think will happen, then see what happens, and if your prediction is ever wrong, walk through the code in your mind one frame at a time to understand exactly what is happening. This will greatly improve your debugging skills of finding and solving problems in your games later on. While you get better at thinking one frame at a time, PICO-8 also offers an easy way to run one frame at a time. So let me show you. Let's run our game and press escape quickly to pause the game loop. The game isn't fully stopped, just paused. If we press Ctrl+R or type run enter, then we completely restart the game. However, we can use the command resume to continue the game at the point where we paused it. Enter, escape, resume, enter, escape. Cool, that's good to know. But we can also resume one frame at a time. Let's restart the whole game and pause it quickly. Now just type a dot, the full stop or period, and press enter. It resumed, but only by one frame. We can use the dot again, but it gets even easier, because after using the dot, you can simply press enter to do it again. And all I'm doing now is pressing enter again and again to run the code frame by frame. This is super useful to help you debug and confirm what you think should be happening in each frame. Alright, go play around with the game loop, drawing shapes in the draw function and changing variables in the update function. And now you're able to animate things on the screen. Thank you to our Ko-fi members who are supporting us to make more free content like this course. Become a member by clicking the link in the description or on our website, nerdyteachers.com.